Hello and welcome to another video. In this one, I'm going to be going over a vulnerability that I found in GitHub Actions recently. And I'm also going to go over my experience with reporting to bug bounties and also my opinions on those and why I think that they're kind of fundamentally flawed. But without further ado, I'm going to start with describing this vulnerability and demonstrating it in a repository. This vulnerability allows an unprivileged user to access secrets in a repository that they don't own just by sending a pull request. And these secrets could be basically anything. In some of the repositories that I looked at, I found anything from commit access to the repository to access to AWS and GCP accounts or Docker Hub or all sorts of different credentials. And I'm just going to demo an escalation on one of my own repositories. So anyway, let's jump into it. Okay, so I have set up a throwaway account for this just to demo this. And I'm going to talk about the 4 requirements that kind of need to be met in order for a repository to be vulnerable. And then we'll show some actual hack in my own code. All right, so we're going to be looking at 2 workflows today. I've labeled them CTF1 and CTF2. And we're going to start with CTF1. This is the bare bones simplest thing to break into here. Now, and first let's start with the 4 prerequisites that need to be met in order for something to be vulnerable. The first and foremost is that it has to use the pull request target trigger for GitHub Actions. Now note that the pull request target trigger runs on pull requests but has access to secrets, and so this is kind of a privileged pull request event. And this is GitHub's docs on this. This red box was not here before I reported this vulnerability, but was added in response to me reporting this vulnerability. This is the resolution. However, you'll see in a second that repositories are still vulnerable to this, and this is something to still look out for. But yeah, this event runs in the context of the base of the pull request, so it's going to run the configuration of the main repository, not the configuration that's in the pull request. So at least that's defended against. And this prevents executing unsafe workflow code. Well, we're about to see in a second that this is not exactly true. But yeah, basically pull request target runs on pull requests, but it has access to secrets from the main repository, and it uses the configuration from the main repository. So anyway, that's the first requirement. It has to use the pull request target. The second requirement is it has to check out the code from the pull request. I've seen this pattern in quite a lot of repositories where they'll use the actions checkout and they will target a ref that is the pull requests merge reference. And so this will check out the actual code from the pull request. This would be needed if you need to lint a pull request or run tests against it or do other stuff like that. And the third requirement is that it runs arbitrary code from the pull request. This could be anything from npm install to make test to installing something from PyPI or anything like that. It basically needs to run some command that will be able to be escalated to arbitrary code inside the pull request. This is usually pretty easy. In this particular example, I've chosen a very, very simple arbitrary code execution, which is that it runs a make target. So it's just going to run make test in this repository. And the last and final requirement for something to be vulnerable is that it needs to expose a secret to the workflow. In this example, I'm exposing this secret directly to this make target, and so you can imagine this is very easy to exploit. I'm going to show you a separate one which requires a little bit more effort in order to expose this secret. So it doesn't necessarily have to be exposed directly to the command that you run. It could be exposed in any future commands, and sometimes in previous commands. So for instance, like one common pattern that I saw was with Docker login, where they would use a GitHub action to log into Docker Hub so that they could pull particular images. And Docker login stores the credentials on disk, and so if you run a command after that Docker login, you can access those secrets. We're also going to be doing some clever things in order to expose this secret via the output of GitHub Actions. By default, GitHub Actions will filter any secrets that it sees in output to kind of have a first line of defense for accidentally printing out a secret. But you'll see that it's pretty easy to get around that, and we'll show that in a bit. Okay, but those are the 4 prerequisites. pull request target, checks out the pull request code, runs arbitrary code, and exposes a secret. And those are pretty easy, and there's quite a lot of repositories that did this and still continue to do this. I have a little script that searches for this across GitHub, and I probably find like 15 to 20 of these that spring up each week. But anyway, let's get into hacking this particular pull request workflow. So the first thing that I'm going to do for this is I'm going to fork this repository as my user. So we will fork this to acetilly, and I'm going to clone it here. github.com acetilly / I think it was GHA test, GitHub Actions test. Yes. Okay, so I'm going to make my own version of this repository. Git checkout origin master -b. Oh, it's origin /main -b ctf1. So we're going to try and break that first GitHub action here. So if we go back to here, so in this case, it is very easy to expose this secret because this secret is exposed directly as an environment variable to our arbitrary code execution. So all we need to do here is adjust this arbitrary code execution to print this secret. Now I'm going to show you what I talked about before, where if you just print the secret outright, then, oops, we need to expand tabs. My editor doesn't quite know about tabs all that well yet. We are just going to print this secret out directly, and I'm going to show you what I was talking about before. So it's example secret, and quote that because, oh my, the highlighting is not so good there. But anyway, we're going to do that, and we're going to commit this. Capture flag 1, attempt 1. And we're going to push that up, and I'm going to make a pull request from this. Now this won't actually expose the secret here because I have not printed the secret or I've just printed the secret verbatim, and GitHub will filter that, fortunately. So if we create this and we wait for this to run, we should see in our output like 3 asterisks where we would expect the secret to have been exposed. And if we look at this now, we're looking at CTF1. We'll look at CTF2 in a second. CTF2 takes a little bit more complicated approach and has the secret exposed in a future job. But you'll see when we run tests here, oh, maybe that's why. How do I print variables in makefile again? We're just gonna run a script. That's gonna be the easier way to do this. T.sh user bin and bash echo example secret. Let's see. Expose secret attempt 1. It wouldn't be live coding without very simple mistake. I think I forgot parentheses. It's been quite a long time since I've written make. I thought it would be easy to expose here, but anyway, we push that up now. We should get another check run here. And if we again look at CTF1 and wait for this to succeed, it should print out 3 stars here, which is not going to help us in capturing that flag. We need to do one step further to, kind of trick our output here. So you can see here that it, it printed 3 stars. That's where the secret was. The secret doesn't, it doesn't actually contain 3 stars. This isn't a Hunter 2 situation. However, it's very easy to encode this. So let's say we pipe the secret into base 64. This will now put base 64 into the output, and we can then decode that on our machines to capture that flag. Capture it as base 64. And we'll push that up and try this again. So just refresh this, wait for GitHub Actions to run. Sometimes it takes a little while to trigger, especially because we are kind of rapid firing here. But now you'll see, and the secret isn't anything special. It's an intentionally, hard-coded example secret. Okay, so if we look here, oh, they have started doing some amount of filtering on base 64 outputs. Interesting. I had not seen that before. Well, we can take this one step further. How do we want to handle this? Let's see. We can do a hex dump. Yeah, let's just do a hex dump. That's another way we can do this. Hex dump instead. Try that. This should get through, surely. And if we run this again, wow, they've found a few more things since last time I was trying to break this, which is a good sign. But it's also, again, like, this isn't really protecting against the problem. It's just obscuring the problem a little bit further. But you could imagine, you could encode it with some key, for instance, and get an example there. But anyway, here you go. You found the secret. We've been able to expose our secret here, which is kind of neat. But let's talk about another one, which is slightly more complicated, and that's ctf2.yaml. In ctf2.yaml, we have a lot of this. We have all the same prerequisites set up. So again, like, it's a pull request target. It checks out the code of the pull request. It runs some arbitrary code. But in this case, we're exposing our secret to a future action that happens after this command. And you might think, I don't really have control over this code, and I can't change the actual YAML of this file. How would I be able to expose this secret? And for this, we're going to take a technique that actually comes from another GitHub Actions vulnerability. This one was reported by Google a little while ago. And I'll link this in the description. This is Project Zero, which is Google's like 0-day, bug bounty sort of thing. And in this one, this is a different thing that's already been fixed. There used to be a way to print stuff to output, which would change variables or path or all sorts of different things, and could lead to a bunch of different, exposures from that via setenv. But there's a useful bit of code in here which shows that if you set node options to a very particular string, it will dump the process environment. And in this case, they encode it using hex. I was doing base64, but hex is another good example. So if you, for example, let me grab a little string from, actually, we can just grab this string here. For example, if I set, export node options equals that string, yeah, that looks fine. Ah, dang it. There's a new line in the middle of it, which breaks this. ToString hex. I think that was the string. Yeah, here we go. So if we set this and then we do node, what happened here? Oh, I forgot some parentheses. How many parentheses do I need there? One more parenthesis. If we run node now, you'll see that it has dumped out my environment just as a side effect of having this environment variable set. And so if we can control this environment variable somehow, and we can't do it from setenv because we saw that that was fixed from this, but we can control the environment file, which was GitHub's fix to printing in setenv to fix this. So we can get, the dumped environment there. I actually hope I don't have anything too secret in there. That's, okay, we're good. Wouldn't it be funny if I was showing you a vulnerability and then I dumped some credential as part of showing you the vulnerability? But anyway, let's do CTF2 now. Master-b origin/main CTF2, and we are going to edit the make file again, and I'm going to again run the test, some t.sh here, user bin env bash. And we are going to take a bit of code that I've written before. Again, it looks like they have fixed base64, so I'm going to do hex instead, I guess. And this is similar to that. We'll see if hex works. If it doesn't work, you could imagine that I could change, I could run arbitrary code as part of this setup here. So I don't necessarily need to stringify this to the output to recover it. I could just run a subprocess directly. Like I could run hd-c, similar to what we did with our shell script there. But let's take this, chmod plus x t.sh, and this should make it so any future Node.js-based GitHub Actions will spit out their credentials. And of course, you can imagine this also working for any arbitrary executable. You could have something like ld preload, which changes how the initialization of libc works, or any sort of thing. Especially because GitHub Actions run on a virtual machine with root, you could even just replace out the file system or change any executable that's going to get run to have your own arbitrary malicious code in it. Attempt to capture flag 2. And we'll create a pull request for this one as well. And I mean, it might not actually capture our flag because of the filtering that it seems that they're doing with base64. Presumably, they're also doing the same filtering with hex as well now, which would kind of foil this demo, but you get the idea. But let's see. We'll see what happens here. Okay, so we want to look at CTF2 and see what happens here. And then I'm going to tell you about my journey in reporting this bug to companies. I found vulnerabilities in many very large companies and many very small companies. Oh, cool. So we got our environment here. So we hex decode in JavaScript. Node s equals, oh, we still have that thing from before. This is the big long environment that we had before. Why is this so slow? I don't know. But anyway, you can imagine, dumping this out, and this contains all of the environment. And GitHub Actions are implemented by passing environment variables. So when you see these inputs in CTF2, each of these inputs here, these are passed as an environment variable with, I think it's input underscore as the beginning of it. And so you can recover all of these values directly from the process environment. And GitHub does not clear these when the actual action is running. So also, inputs that the action doesn't take, those also end up in the environment as well. So I could pull out this secret directly from this environment. Wish I could have used base64 instead. Actually, let's try base64. Maybe it's possible that just because my shell script, it was filtered out. Let's do base64. We can also just do it reversed. Reverse a string JavaScript. 3 ways to reverse a string. Okay, cool. Surely this will be helpful. This is not reversing a string. That's just the same string. Oh, I see. They're like TDDing this out. Oh, there's dot reverse. Oh, split dot reverse dot join. Yeah, we'll just do this then. To string buffer from stringify. Let's see. Dot split dot reverse dot join, and then we need to delete this. Yeah, let's try that. Print environment reversed. I have a typo there, but whatever. Okay, so this should should print out. What was our test string again? I forget. I guess we can look at it from here. Our test string was, you found the secret, so we need to look for the word secret, but backwards. Okay. Station. TF2. Oh, it failed. Why did we fail? Buffer from dot split is not, oh, because it's a buffer. I need to do dot string. Anyway, you get the idea. I could fix this up and get it printing out the secrets there. But now I want to talk about my experience in reporting this. So I reported this, I believe it was the 27th of November. Oh, I guess I should talk about how I originally found this. So I originally found this, I maintain a set of GitHub actions myself, and one of the actions involves running linters, and for private repositories, it allows you to commit those changes back to the branch. And someone had proposed, enabling pull request target for doing the same thing. And I pointed out, this was actually months before I realized that it was a security problem, I pointed out that this allowed arbitrary code execution and was not something that I really wanted to support. And I thought about it later in November and reported this on November 27th to GitHub via HackerOne. And GitHub got back to me within a few hours and said, we are investigating this. We'll let you know when we follow up. And then 2 months passed from then, and also at the same time, while while I reported it to GitHub, I also found about 350 repositories that had this same vulnerability, and I started reporting this vulnerability to individuals. Some of the repositories in question are owned by very large companies. For instance, Google had several repositories, Microsoft had quite a few repositories, AWS had one, Alibaba had one, and then a spattering of other people also had repositories that were vulnerable to this bug at varying levels of degree. Almost all of them allowed arbitrary code execution or arbitrary changes to the repository under question because they exposed the GitHub token secret, which is an automatic secret that's exposed to all GitHub actions. And in the pull request target flow, it has write access to the repository. Let's see. Is this all about that? GitHub token. About the GitHub token secret. So this has, where do they list the permissions? Here are the permissions. So it can, and it has this column of access because it is a privileged job. So it has read and write to actions, read and write to checks, contents, read and write. This means you could write anything to the repository. It can read and write deployments. I don't know what deployments are. Oh, I guess this is maybe like releases and stuff. It can read and write issues. It can read metadata. It can write packages, pull requests, etc. The big one is probably contents. And so, if you expose GitHub token to a privileged job and something has access to that, it now has access to your full repository. And almost all of the bounties that I opened were closed as informational and did not, were not given a bug bounty, despite having, broad access to their source code repositories and related services such as AWS, GCP, Docker Hub, etc. And a few of them are a little bit ironic. I found vulnerabilities in at least 3 security startups, including one security startup that is a security bounty startup. And none of the 3 security companies that I, disclosed to, and they fixed the bug, and then, didn't pay out, which I thought was kind of funny. But yeah, GitHub got back to me 2 months later and said that this doesn't fall under the category of high risk. This is a low risk thing. Despite, and I know this because some of the companies that I contacted reached out to me and were like, hey, GitHub reached out to me and told us about this vulnerability. And so, we're really glad that you showed us this, but GitHub is also letting people know about this. GitHub also published a blog post specifically about this vulnerability called Keeping Your Actions and Workflows Secure, Preventing Own Requests, where they specifically talk about the pull request target. And this was published a month after I reported this bug, which I thought was pretty interesting, that they would publicly disclose this without actually fixing the problem, as well as showing, all of the various steps here. This is also why I don't feel bad about publicly disclosing this in a YouTube video, because GitHub has already done this themselves. So, if they're doing it, I'll be fine doing it too. And GitHub eventually closed it as informational and gave me a bounty that is below their minimum threshold for bounties. So, not only did they not really follow through on their bug bounty program, but they also, here's some tiny pocket change so that you don't complain about it. But you know what? That's bullshit, so I'm going to complain about it. Is there anything else I want to talk about? I don't think so. But anyway, basically the end game of this is probably don't use pull request target. There are a few strategies to still use pull request target and still expose secrets without having them exposed to all pull requests. One strategy is to require your pull request targets to be on label. So you would have to manually have a pull request reviewer label the pull request to run those privileged jobs. This kind of puts a human in between those sorts of things happening. Another way is to split up your GitHub actions. So you have a first chunk of GitHub action, which, checks out the user code, does some processing based on it, and then produces an artifact, and then have a second privileged job, which consumes that artifact and does the privileged things, while being careful to not run any code from that artifact. So that's one way to kind of solve this sort of problem. But my advice is don't use pull request target. It's too easy to accidentally leak your credentials doing this, and so yeah, don't do that. But anyway, my name is Anthony. If you are new to the channel, because I expect some people will be new for this video, because this one's kind of different from my normal content. I stream programming on Twitch several times a week at twitch.tv/AnthonyWritesCode. I also produce a lot of open source software in Python, so you can sponsor my GitHub if that's something that you're interested in. But thank you all for watching, and hopefully I will see you in the next one.